Here's example 11 of evaluating trig with inverse trig. So we're going to use this flowchart that we've been using. And if you want to copy this flowchart to follow along with, check the video description. There's a link in there. You can click that link, open this up, print it out, and follow along if you'd like. So let's go ahead and get started. Is there a domain violation? No, there's not, because we can take the cosine of anything we want. Okay, so what do we do in example 11? We have inverse sine of the cosine of 3 pi over 8. And the domain of the cosine function is all real numbers, so we can take the cosine of whatever we want. Now, when we take the cosine of something, we're going to get something that's between -1 and 1, which means it's going to be okay to put back into the inverse sine function. So inverse sine of cosine of this thing here, it's going to be okay. There's no domain violations, nothing bad is happening, everything's fine. Is there a domain violation? No. Is the function paired with its inverse? No, it's inverse sine paired with cosine. So it's not inverse sine and sine, it's not inverse cosine and cosine, it's inverse sine with cosine. So, no. Is the function paired with its own inverse? No, it's not. Can the problem be solved using the unit circle? In other words, is 3 pi over 8 some nice angle on the unit circle? No, it's not, right? It looks like it might be because it's some number times pi divided by another number. But stuff like that over 8, those are not nice angles that are on the unit circle. Okay. So no, we cannot solve these using the unit circle. Can the problem be solved using the unit circle? No. Is the inverse function on the inside? No, the inverse function is on the outside. Okay, inverse sine appears on the outside, regular cosine on the inside. Is the inverse function on the inside? No, follow the no path. Is the function paired with its own inverse? We already asked that, but remember, like we said in the previous video, we have to ask it again here because it does affect what happens next. And again, the answer is no, the function is not paired with its own inverse. It's inverse sine and cosine. Okay, so no, the function is not paired with its own inverse. So no. Is the function paired with the inverse of its cofunction? Now that might sound like a mouthful, but let's break down what that means. Is the function paired with the inverse of its cofunction? So what's the function? Cosine. So is cosine paired with the inverse of its cofunction? Remember that term cofunction? What's the cofunction for cosine? The cofunction for cosine is sine. So when we say inverse of its cofunction, what we mean is the inverse of sine. What's the inverse of sine? Well, it's sine inverse, right? Sine inverse. Is cosine paired with sine inverse? Yes, cosine is paired with sine inverse. Okay, so again, when we ask this question here, is the function paired with the inverse of its cofunction? So in other words, is the function cosine of x paired with the inverse of its cofunction? So in other words, here's the function. Is the inverse function the inverse of the cofunction? Well, if cosine is the function, then the cofunction is sine. The cofunction is sine. The inverse of the cofunction is inverse sine. So yes, the function is paired with the inverse of the cofunction. Okay. So if you just think of it like this, it won't be too confusing. Is the function paired with the inverse of its cofunction? Okay, is cosine paired with the inverse of its cofunction? Its cofunction is sine. The inverse of sine is inverse sine. That's it. And yes, the function is paired with the inverse of its cofunction. Okay, okay, so yes. So then we use the complementary angle theorem, and then after that we can either cancel or use reference angles. Okay, so remember the complementary angle theorem? Let's erase this here so we have more room to work. So the complementary angle theorem says a lot of things, but the way it's going to be more useful to us is cosine of x equals sine of pi over 2 minus x. Okay. Why do we want to do that? Well, because if we do this, we're going to replace this cosine basically with a sine, and then we'll have sine inverse paired with sine, and that'll be nice because it's nice to have functions paired with their own inverses, because then it's usually a little easier to work with. Okay. So remember, this is one of the things the complementary angle theorem says. We talked about that a long time ago. Anyway, in this specific case, cosine of 3 pi over 8 equals sine of pi over 2 minus 3 pi over 8. Okay, so in general, cosine of x is sine of pi over 2 minus x. In this specific case, we have 3 pi over 8. So cosine of 3 pi over 8 is sine of pi over 2 minus 3 pi over 8. That's from the complementary angle theorem. Now, What do we have now? Okay, so then now we just simplify this. So this is sine of, get a common denominator, so multiply this guy by 4 over 4. So that's going to be 4 pi over 8 minus 3 pi over 8. Okay, so 4 pi over 8 minus 3 pi over 8 is pi over 8. So this is sine of pi over 8. Okay. Okay, so that's what we have going on there. Now, in other words, what did we just find out? We just found out that cosine of 3 pi over 8 is the sine of pi over 8. Therefore, inverse sine of cosine of 3 pi over 8 is the inverse sine of pi over 8. Okay. So cosine of 3 pi over 8 equals sine of pi over 8. That's what we just found out here. Cosine of 3 pi over 8 equals sine of pi over 8. Therefore, inverse sine of cosine of 3 pi over 8 equals the inverse sine of sine of pi over 8. Okay, now if we go back to the flowchart, what did it say to do? It said use the complementary angle theorem, which is what we just did, and then either cancel or use reference angles. And now here we can cancel, right? Because remember, what was the rule for canceling inverse sines like this? So again, first we use the complementary angle theorem to convert this cosine into a sine, and that's why we asked the question, is the function paired with the inverse of its cofunction? And the answer is yes, and because it is, then we can use the complementary angle theorem to do this, okay? And actually get the cofunction instead of just the function. Okay, so now the rule for canceling is inverse sine of x equals x if negative pi over 2 is less than or equal to x is less than or equal to pi over 2. And pi over 8 absolutely totally is. Okay, pi over 8 is between negative pi over 2 and positive pi over 2. So therefore, we can cancel. Okay, equals pi over 8. And that's the answer. Inverse sine of cosine of 3 pi over 8 equals pi over 8. Okay. Now I do want to point something out. This says use the complementary angle theorem. And remember, the complementary angle theorem says this cosine of x is sine of pi over 2 minus x, but it assumes that x is some other acute angle. Well, I want to point out that this is actually true for any value of x. So the complementary angle theorem is true not just for acute angles, but also just for any value of x here. So it is important to keep that in mind. It's actually a special type of trig identity, but since if you've been following these videos in order, we haven't really talked about that yet. It's coming up a little bit later. It's a special kind of trig formula. It's coming up a little bit later. We haven't talked about that yet, but this is true for all values of x. Okay, true for all values of x. So even if 3 pi over 8, so that is acute, so it's okay as far as the complementary angle theorem goes. But even if this was not an acute angle, you could still use this here. Okay, so even though this says use the complementary angle theorem, the complementary angle theorem sort of implies that this has to be an acute angle, because that's how we introduced it way back then. But again, this is actually true for every value of x. So, and the same thing is true for, the complementary angle theorem says a bunch of different things with all 6 different trig functions. And actually the same thing is true for all the other ones. As long as there are no domain violations, you can just plug in any value of x, not just acute values. Okay, so just want to point that out because it is important to keep that in mind. Anyway, that's example 11 with of evaluating trig with inverse trig, and another example using this flowchart here. More stuff coming up in the next few videos.